Hey, my name is Milan, and in today's video we're going to talk about output caching and how we can use it to improve the performance of our .NET applications. Of course, as with any caching approach, it doesn't come without its drawbacks, so we're going to discuss what they are throughout this video, so let's dive in. I'm going to start by showing you how easy it is to set up output caching with a .NET API. I have a getUser use case here, and it exposes an endpoint which uses minimal APIs, and then our handler is just going to execute an EF core query that's going to return a user response. So all you have to do to introduce output caching here is to call the cache output method in the minimal API endpoint definition. This method has a few overloads that we're going to discuss a bit later, but for now all you have to remember is that we have to call cache output on our minimal API endpoint. If we are using controllers, and this also works with minimal APIs, we can decorate this with an attribute called output cache, and it's going to do the same thing. Now, the next thing we need is to introduce a few services and a middleware. So let me introduce the required services here. You have to say builder services and output cache. You can also configure this further, and we're going to explore all of this a bit later, but I want to quickly set this up and show you how this works in practice. And the last thing we need is an output caching middleware. So you will have to say app use output cache, and this is going to introduce the respective middleware that actually does all of the output caching magic. Now, it's also recommended that you introduce this middleware later in the request pipeline, preferably after authentication and authorization, because you don't want to accidentally cache unauthorized requests. So with this setup in place, let's start the application. If I open up the Swagger UI, I have a set of endpoints, and we introduce caching on the get endpoint to fetch a user by their identifier. Now, if you recall, this method doesn't have authentication on it, so I can just input a user ID. Here is one for a user I already created, and if I send this request, we're going to land on this breakpoint in our minimal API endpoint because our output cache doesn't exist yet. So I'm going to press continue. We get a response back in our Swagger UI, and now if I send this request again and I can continue sending it, you will see that I'm not hitting my breakpoint even though it's still there. This is because our output cache is now functional and our response is working. So let me give you a bit of a high-level view into output caching before we dive into the fine details. Let's spend a quick moment to discuss what output caching gives us and where it fits in the broader view of a web application. This is going to be a TLDR so that we don't spend too much time on this, but essentially output caching allows you to cache HTTP responses, and this is important, and by default we can only cache the responses to GET and HEAD requests. You also have to know that output caching by default uses the available memory on your server. So if you are running in a distributed environment, meaning you have multiple server instances, the output caches will not share the same memory. So if you want to scale out, you will have to use a proper distributed cache like Redis. When it comes to evicting output cache entries, you can either use cache expiration, or you can manually invalidate your cache entries so that they are removed from the output cache. And output caching also has locking built in by default to prevent the cache stampede or thundering herd problem. Now let's discuss where output caching fits into our web application. For example, we could have a web application or a mobile client talking to our application, which talks to a database to return back the required data. And when we send a request to our application, we can reach out to the database, fetch the required data, and then output cache the response. So what we are actually caching here is the response to an HTTP request. And this is an important distinction from regular application level caching, where you decide to store some object into your cache and then retrieve it based on the cache key. Here we are caching an actual HTTP response. And this response doesn't have to be a JSON object, which is common for RESTful APIs. You can also use this in an MVC application and cache an entire page that you return to the client. The next time any of these clients reach out to your application to fetch the same resource, we no longer have to reach out to the database, and we can serve the response that we have in the output cache. And this helps us reduce performance because we don't have to reach out to the database as often, and also it reduces the load on the database so that it can serve other application queries. So that all sounds nice and great, but there are also some drawbacks when it comes to output caching. So let's jump into the code and explore this further. Let's put our attention on the cache output method, and let me show you what you can configure with the overloads that we have available. You can specify an output caching policy by its name. You can also provide an instance of the iOutputCache policy interface, which is the actual output cache policy implementation. And then you have an option to provide an action that's going to use an output cache policy builder. So let's explore this one. When you access the builder, you have a set of methods that you can use to customize the cache output policy that you want to use. You can provide a custom policy using the add policy method. You can decide if you want to actually cache the response of this endpoint, or you can call the no cache method, and this is going to prevent caching the response of a particular endpoint. And this is relevant because you can define a global output caching policy, which you may want to turn off for specific endpoints. You can also configure the expiration time using a time span. So let's say that I want this to be valid for 1 minute. And after that, this cache entry should expire. This is how you would do it. But of course, you can continue chaining method calls to customize this output cache policy. For example, you can decide if you want to enable locking or not on this endpoint. By default, it's going to be true because this is required to prevent the cache stampede problem. This happens when a cache entry expires and you have a large number of concurrent requests trying to execute the same endpoint and then cache the response. This is going to cause unnecessary requests going to your database, and locking prevents this by only allowing one request to reach out to the database and cache the response, and then all of the other requests that are stuck on the lock are going to realize that there is a response available in the cache and then return that instead of reaching out to the database. I also discussed this problem in a recent video about the cache aside pattern, and you can go ahead and watch that video after you're done with this one. Now let's go back to output caching. I'm going to revert this because I don't want to tamper with locking. A few more things that you can configure here is how you want to vary the caching policy. By default, the entire URL of an endpoint is going to be part of the cache key. So if we change the user identifier here, that is going to create a new cache entry. But if you want to vary by some other parameter, for example, you want to vary by a specific header, by a host, by the query parameters, by a route value, like the ID in this case, then you can configure this by calling one of the vary by methods. Another thing that is very interesting, and we're going to use this, is the concept of tagging, where you can tag a specific cache output entry. For example, I already have the concept of a tag for my user endpoints, which is just a constant with the name of users, and I'm using this to group my minimal API endpoints for the user's resource in the Swagger UI. You can also use this to tag your output cache entries so that you can later evict them based on the tag value. So this is how you can invalidate specific output cache entries without having to remove all of the cached values. So let's say I'm satisfied with this output caching policy, and now I want to scale out my output caching using Redis. Here is how you can implement this. We need to install an additional NuGet package into our application, and you're going to search for output caching Stack Exchange Redis. So let's go ahead and install this NuGet package. I will add the latest version, and then let's close this down, and I'm going to go into my program file, and I will say builder services, and I need to call the add Stack Exchange Redis output cache method. I can also configure the output caching options with Redis, and the two things I want to set are the configuration, which is my connection string to the Redis instance. So let's say builder configuration get connection string, and for example I will have a Redis connection string. Let's assign that. And another thing you can do is introduce an instance name, and this is going to prefix your cache entries with a specific value. So let's say I add a calconnect prefix so that I can know which cache entries are coming from the calconnect application. And now all we need is a Redis instance, and I can go ahead and introduce a Redis instance in my Docker Compose setup, but let's actually use a proper Redis instance, and you can easily create a Redis instance in Azure. So if you open up the Azure portal, you can go into the Azure Cache for Redis service, and here you can easily create a new Redis instance. You will have to choose your subscription name, a resource group, enter a value for the URI, choose your location, which type of service level agreement you want, and then the most important thing is the actual size of your cache instance. So you can choose between 250 megabytes, which is probably enough for development, up to 53 gigabytes on the standard SKU. But if you choose something like Enterprise, you can go up to 400 gigabytes. And if you choose Enterprise Flash, you can even go up to 1455 gigabytes. So that's a lot of memory available for caching. When you're satisfied with your choice, you can go ahead and create an instance. I already created one, so let's use this one. It's a standard Azure Cache for Redis instance with 250 megabytes of memory. And what I want to do here is to grab a connection string for my Redis instance. So if you go to settings and authentication and then access keys, you can copy a value for your connection string and configure it with your application settings. So let's go ahead and copy this value, and then I'll go back to Visual Studio, and I'm going to add this value in my user secrets. So let's click Manage User Secrets. I have a connection strings Redis configuration value, and then all I need to do is to paste the actual connection string, and this will be enough to connect to the Azure Cache for Redis instance. So let's go ahead and start our application, and I'm going to send the same request to our API to fetch a user with this identifier, and remember this time we are using the Azure Cache for Redis service for the output cache entries. So if I click execute, we're going to land on this breakpoint, which is expected. We don't have a cache value yet, so let's press continue, and we get a response back in Postman. And now if I hit execute, you will see that this value doesn't hit the breakpoint, so it's probably served from the cache, right? But how can we be sure? If I go back to my Azure Cache for Redis instance, I can go into the console, and from the command line interface, I can run the Redis CLI commands. So I'm going to execute keys and then star, and this will give me all of the keys that are present in this Redis instance. And you can see a cache entry here where the cache key contains localhost 5001 users, and then the identifier of the user that we were trying to fetch from the database. So this is our actual output cache entry, and you can see there are a few more values which are all prefixed with calconnect, so the configuration that we put in place is working as expected. And we are also sure that we are serving the output cache response from our Redis instance. Now I'm going to make a simple change in this endpoint, and all I'm going to say is require authorization. And then let's start the application and try to send the same request again. So remember, we are still using a Redis instance in Azure, and this Redis instance already has this value cached. So let's send this request. And as expected, we get a 401 unauthorized response because it didn't provide a JSON web token. So I'll have to get a JSON web token. Let me do that through the login endpoint. Here is my JSON web token. And then I'm going to authenticate through the Swagger UI, and then let's send this request again. And you can see that we hit the breakpoint on our endpoint. So maybe the cache entry expired and we're going to cache it now. So let's press continue. And if I send the same request again, you will see that I hit the breakpoint again. Let me press continue. I'll send it again. It again hits the breakpoint. So you can see that for some reason, when I send this request, it is no longer being served from the output cache, and my endpoint is always executed and I'm reaching out to the database. So why is this? So to figure this out, let's go into the code for the cache output method. And you can see that there's an interesting argument here. This is a Boolean argument with the value of false. And if I go into the next method, the name of this argument is exclude default policy. And we are specifying false by default, which means we want to include it. Now this is used in the output cache policy builder. And you can see that when this is false, we're going to include a default policy instance. So let's go into the default policy. And this is the base policy that is configured when you enable output caching. And from the summary of the default policy, you can see that this is a policy that caches unauthenticated GET and head requests with a 200 response. So this is why our output cache is no longer working, because we are sending an authenticated API request. There is a reason this is the default policy, because caching authenticated requests can open you up to some interesting problems, and I'm going to show you what they are. But for now, let's try to get around this by creating a custom policy that's going to be based on the default policy. So I'm just going to copy all of the code that you see here, and let me create an output caching folder in my API, and inside of it we're going to create a new class, and let's call it the custom policy. I'm going to paste in the default policy implementation. Let's rename it to custom policy. It's going to have a public constructor and it won't need a default instance. Of course, I have to rename the constructor, and then I'm going to fix the few code analysis warnings that I'm getting here so that all of this code is compiling. And then let's focus on this part here, which is responsible for checking that the current request has an authorization header and the current user is authenticated. So this is the part that's preventing us from caching authenticated requests. So I'm just going to comment this out, and now our output caching should work when we are specifying a JSON web token. And you can also extend this further by enabling caching for different HTTP methods. For example, if you want to cache post responses, you can do that by adding a respective condition here. But this is the only change that I'm going to make in my custom output caching policy. And now the question is, how do I enable it with my output caching services? You can provide a delegate when you're configuring output caching. And this will allow you to specify a base policy. We have to use an output cache policy builder, and I need to call the add policy method. And I'm going to specify my custom policy. Let's also add a cache key prefix for this custom policy, for example, custom, so that we are aware which cache entries come from this specific policy. And it's important that you specify exclude default policy so that it's no longer included in our setup. If I go ahead and start my application now with my custom policy configured, and we configured it to override the default policy, we can expect that when we send this request, it's going to be stored in the output cache and served from the cache after this initial request completes. But if I keep sending this request, you will quickly see that for some reason this isn't working. So if I go back to my code, you will find that the fix for this is quite simple, but unfortunately it's not so obvious. You will have to exclude the default policy from the specific call to cache output for our custom policy to be enabled. If you don't include this value, the default policy is going to win and it will be used by default, even if we have a base policy configured in our output caching setup like we do here. But now everything should work as expected, and I want to use this to highlight another issue. I'm going to inject another service here, which is going to be the claims principal, and I want to use my claims principal for a simple resource authorization check. So if the identifier of the user that we are trying to access doesn't match the identifier of the currently authenticated user, then you're going to return a 403 forbidden response. So let's go ahead and start our application, and let's send our request to the server. And here we're going to do our check. You can see that these values match, so we can now go to the database and retrieve the user. If I send the request again, you can see that we are no longer hitting the breakpoint because our output caching is now working using our custom policy. But now let me show you what problem we can run into. I'm going to open up another Swagger UI instance, and I'm going to authenticate with a different user account. So it's going to be test1@test.com. Let's send this request. Let me grab the access token here. We're going to authenticate using this access token, and then I'm going to use the identifier of this user and try to fetch this value. So if I send this request, we're going to hit the breakpoint, and you can see that these values don't match. The identifier that I specified here doesn't belong to the current user. So we are not going to cache this value. And if I keep sending this request, we're going to keep getting a 403 forbidden response. But now if I send this request from this Swagger UI instance, where this is the current user, you can see that I'm getting back a response, and now this value is present in my output cache. But now let's go back to this Swagger UI tab where we have a different user, and if I send this request again, you can see that I'm getting the response back because we are able to pull the value from the output cache based on the request URI, and it doesn't take into account who is the current user because our logic for checking that is inside of our minimal API endpoint. So this is a huge security concern with caching in general, and it's even more prevalent with output caching. And this is another reason why the default policy only allows unauthenticated requests, which are considered safe for caching. So how are we going to solve this problem? We will have to update our output caching policy. So by default, we have an expiration time of 1 minute. We are tagging our output cache value. And another thing that we can specify here is the vary by. And I want to vary by a custom value. So I'm going to provide a delegate that gives me access to the HTTP context. The other value is a cancellation token, but I don't care for this. And what I can do here is return a value that I'm going to use to vary my response. So this is going to be a key value pair. But actually, since this is an async method, I will have to say value task from result. And then I can specify my key value pair, and then we have to provide a key and a value. Let's say that my key is going to come from claims principal extensions, and I'm going to use the user ID method, and then the value will come from my HTTP context. I'm going to say HTTP context user, and then give me the user ID value, which I will have to convert into a string. So now I'm going to make a distinction of my cache entries based on the user identifier of the currently authenticated user. So let's see if this makes a difference. I'm going to start my application again, and let's send a GET request for this user. So we're going to hit our breakpoint, go past the if statement. So we are able to fetch this user from the database, and now it's going to be served from the output cache for the current user. Let me switch over to the other tab, and now let's try to access the user with this identifier for a different authenticated user. So this time you will see that we land in the breakpoint even though the value is present in the output cache, and we're going to return a 403 forbidden response. And if I keep sending this request, I will not return the output cache value. Instead, I'm going to land in my minimal API endpoint. Of course, if I switch this with the identifier of this user and send the request, you will see that the initial check is going to pass, and we're going to cache this value, and then we can retrieve it from the cache. If I jump into the console of my Redis instance and look for all of the keys, you can see that there is a cache entry for a user with this identifier, but you can also see that there is another value appended to the cache key, which is the user ID. And this is our key value pair that we configured in the vary_by_value method. I'm going to just quickly fetch both of the users from my API to make sure they are all cached. And if I list my cache keys again, you will see that I have 2 cache entries for the user's endpoint, and this is how we can safely use output caching for different users. And there is one more important concept that I want to discuss, and that is cache invalidation. If we were to cache this value for a longer duration, for example 10 minutes, an hour, whatever makes sense for your use case, this value is going to stay in the cache until it expires. And the underlying resource, the source of truth, could change because we update the user, for example. So I have an update user endpoint here, and let's say I want to invalidate a cache entry for the user when the user is updated. I will need to inject an ioutput cache store instance, and we can use this to remove specific cache entries. So let's say after we complete the call to save changes async, and we persist the user's updates into the database, we can say await cache store evict by tag async, and then you can remove cache entries with a specific tag. Now this is a very broad concept, and if you recall, we tagged this user using this value. So I can go ahead and specify this, and when my endpoint executes, it's going to evict all cache entries that have this tag value. You can see how this isn't ideal because we are not specifying a very specific tag entry, which would just invalidate an output cache entry for a specific user. Instead, we have to invalidate all cache entries with a specific tag. So this could be an improvement, but it's also going to remove more cache entries than necessary. And one more thing I want to show you is how you can tag all of your cache entries. You can add another base policy, and you can just say tag with an all tag, for example. And then I want to also specify true to exclude the default policy. And now every time an output cache entry is created, it's also going to contain this tag. And this allows you to do something like this. Let's say I create a purge output cache endpoint, and what I can do here is access my output cache store and evict all of my tag entries with the tag of all. And these are going to be all of my tag entries. So this is a very simple approach how you can purge your entire output cache and start from scratch. So output caching definitely seems like an interesting approach to improve your API's performance. However, you need to be aware of the existing drawbacks. If you want to learn more about caching in general, then I suggest that you watch this video next. Also check out my clean architecture and modular monolith courses to improve your skills. And until next time, stay awesome.